Hello, hello everyone. Welcome back to Paleopark's weekly seminar. And today we have Dr. Sanjukta Chakravorti, and she will be talking about before the dinosaurs, India's lost world of giant amphibians. I hope it's a really interesting topic, and I also believe that you are going to get a lot of information about the Jurassic world, which was exist just before the Jurassic world. So for the seminar, we also had a format of the seminar. So first we have welcome and announcement, which I am doing right now. And then we will be having talk for 30 minutes, which will be followed by the question answer sessions. And please don't forget to send your question to the chat box or to the questions at Valuebucks host, who will be most likely Ahana for today. And our speaker also agreed to stay for the tea time. Tea time is nothing but it's like a more informal chat discussion after the talk. So if you are interested in detailed discussion, you can stay around for the tea time. And we also do some housekeeping announcements. So Paleopucks values the participation of all the folks interested in paleosciences. Please follow our code of conduct during the seminar. And during seminar, you should be muted. If you are not, then please keep muted yourself. And please again don't forget to ask questions by chatting to the questions at Paleopax host or by using the raise hand function. If you face any technical issue, please reach out to the host. And we also have closed caption built into the Zoom. So please you can use the CC button to show or hide them. If you know any outstanding early career researcher whose work is related to paleosciences, please you can nominate them as a speaker. And we also get weekly feedback for demographic info, which is completely anonymous and optional. And for both of them, the link will be shared in the chat box. And finally, a little bit about the today's speaker. So Dr. Sanjukta has done her PhD from Indian Statistical Institute, India, and currently she is a postdoc at State National History Museum, Germany. So with this, I invite Dr. Sanjukta to start the talk. So Dr. Sanjukta, now screen is yours. You can take over the screen and start sharing your slides.
Thank you for the nice introduction. Salman, I'm sure I'm audible.
Yeah.
Okay, so I'll just directly go to share my screen.
Sure.
So thank you for having me as a speaker. And it's a privilege to talk about the Indian paleosciences in general at a time when paleoscience is broadly expanding. So I would like to have a very short introduction about why I chose such a title. Mainly because many people who have been in India or who like paleosciences, paleontology, or whatever you may call it, generally picture dinosaurs, like giant big dinosaurs. But the dinosaurs' gigantism came much later, and there was a whole gamut of world before that. And today we will focus on one particular animal, which are the amphibians, and why they are very important, especially in India. So let's get started. Before the dinosaurs, what was India's lost world of giant amphibians? So I want everybody of you to close your eyes first. Now imagine an India where there is no Barapasaurus togori. There is no giant sauropod stomping the ground, no Rajasaurus chasing a prey. But there were temnospondyls, or there were amphibians, there were fishes, there were rhynchosaurs, dinosaurs, pseudosuchians, all different arrays of prehistoric creatures occupying different kinds of environment or paleo environment, as we can say it. So today specifically, we will deal with the temnospondyls. So why the temnospondyls? That is important. So this is a clip from the BBC where actually you can see that from the fishes coming to the amphibian, the link was the tiktaalik, which still retained gills. But when we come to the temnospondyls, they were amphibian, that is, they lived both on land and water. But the transition from water to land involved immense experimentation and a lot of pain. You have to leave your gills, you have to change your way of reproduction, your way of mating, and above all, you have to go discard or partially discard your dependence on the buoyancy and deal with gravity, which is in itself a huge challenge. And that challenge has to be mitigated from the skulls to the hands. So, here, mainly this documentary was concentrated, as many of you might have seen, on the Tiktaalik and its adventure. But one thing it had very similar, that all temnospondyls, or some of them, had to return to the water to lay their eggs and reproduce. So, that is very important. And ecological niche change was not like instant. It took millions of years, like really millions. And instead of replacing the old Permian life, or after the Permian mass extinction, the Triassic, when it really came, it couldn't just discard with all the gill sizes or all the presence of gills. So temnospondyls were kind of a mixture, a porridge of nature's experimentation, a porridge which was far more interesting than the dinosaurs, because it has gills, it has scales like fishes, it has different body sizes from being minutely small to gigantic, 6 meters or so in their body length. And absolutely, one skull we have here in India which measures about 50 centimeters just in the length of the skull. So it had variations, it had a lot of diversity, and also diversity in the term of skulls, from longirostrian, that is very long snouted ones. You had broad, like tables, like table like skulls. Then you also have the crocodilian type of skulls, because as a paleontologist from ISI, I always gave visits to outreach programs and general audiences, and everybody saw temnospondyle skulls, especially those from the middle Triassic or late Triassic, and thought that that was a crocodile. I mean, I'm speaking of people who are not into paleontology. For them, so let's first give a brief introduction of the pretext that we will be talking today, because temnospondyles also existed before the Permian, but the Permian mass extinction completely destroyed the existing all categories of them, and they all over started a new domain altogether. So, as I wrote here, the world has just been broken. The PT mass extinction was one of the gruesome mass extinction, and its trigger, as you may all know, is the Siberian trap volcanism, extreme warming, acidification, and anoxia. And then it led to a total 90% of faunal killing, both if you combine both land and water, and about 70% of all land vertebrates were dead. They were extinct already. So the pre-extinction, as you can see in the cornermost image, had a pretty wide ecological network. But post-extinction, the recovery was challenging because the climate was hostile, like very, very hostile. And you needed to compete for food. You needed to adjust with everything. So you really needed to start from the scratch. And the recovery, as I said, was an experiment. It was messy. It was absolutely messy. And if you go like a time scale from below to upward, so the depleted post extinction baseline is there, where you have the Permo-Triassic mass extinction. Then you start slowly developing the ecosystem. You have the short food chain, but the animals were very tiny. The temnospondyles, though they came into land, they were diverse, but they had to deal with the other land vertebrates also, which were predatory. So they were simplified in form, they were smaller because that would require much less nutrition, much less like things for them to consume, and fast escape. And also they could experiment more on the different ecosystems and different niches that the challenging ecosystem gave. And then we have the middle Triassic, where there is body size expansion and new predator guilds were completely rising. And in the late Triassic, the niche was partitioned. It was a multi-tier freshwater and terrestrial ecosystem, but the diversity of the temnospondyls through the bottom to the top actually decreased. While in the early Triassic, we will see that there were a lot of different type of species. In the middle Triassic, there was not many. The gradually the species, the diversity of the species started like getting down, and towards the late Triassic, there were barely any, but there was still. Now, here it is a map. So I have colored this map using the help of Gemini, but the map is one which we did our field works in, but that is uncolored and very boring. So here you will see that the bluish turquoise color, that is the early Triassic part, the Son, Mahanadi, Rewa basin, which has early Triassic as, the Damodar Valley basin, which has the mainly the early Triassic and a little bit of the middle Triassic. Then you have the mustard yellow color, the entire middle stretch, which I'm kind of moving with my cursor. Here, it is a Satpura Valley basin. So, for people who don't know India, it is as big as a subcontinent. And to go from the whole of India, it's like a journey. So, in this part, the mustard yellow color part of the central part of India is the dense, famous tiger reserve of India. And then you have the purple parts. The purple is in the central, the south central part of India, which is slightly northwest southeast trending. This one near Hyderabad. That is the famous Pranhita Godavari Valley Basin. And then another purple part. The purple denotes the late Triassic. And so, one thing I want to really stress out here is that you can see within a very short spatial area, you have the entire Triassic concentrated. You have unbreaking sequence of the early Triassic, middle Triassic, and late Triassic, which is rare to find. Like India is the second country or the subcontinent just after South Africa, which have this stratigraphic scenario, and that makes it a very, very important hub for studying this 50 million whole story of the birth and the radiation of the amphibians, the temnospondyls, and their journey from miniaturization to gigantism. What was their entire strategy? So basically, it is 4 basins and one long experiment. So it is a part of my PhD thesis. So I've taken this image from there. And later we published a part of it. So it is early Triassic Panchet, where we have a fluvial lacustrine environment. But nowadays, we think we do have marine sequence there or shallow marine environment. And then you have the middle Triassic Denva Formation, which you remember the mustard yellow colored central Indian part. And then you have the late Triassic Mallory Formation and also the late Triassic Tiki Formation. So these are the two different basins. One is the Pranita Godavari Valley Basin, if you remember the purple south central part, and then the late Triassic. Then why is it important, as I told? Because India was not where it is today. It was a part of Gondwana. And we have these animals also present in South America, South Africa, Madagascar, Australia, and various other, and also some counterparts in different species form in Europe. I will go to that part later. But the most precarious thing is that the closest relative, and not so surprisingly, of Indian speciation we find is that of Madagascar. So I will just give you a short clue of what I was actually speaking about. So if you see the part where it's written Gondwana and this deep brown area and this notch, this part is actually the peninsular India. And later, post the Jurassic, the small breaking started happening. And gradually, India moved towards the as an island continent before colliding towards the northern part with Asia and forming the entire Eurasian part. and the cosmopolitan fauna. But that is what makes India very special, actually, because on the one part you have the peninsular India, the Gondwana, where you have its faunal matching with Antarctica, Australia, Africa, South America, and then you have this entire Paleotethys Ocean, which gave India many endemic faunas, and then you again have the cosmopolitan Eocene, Paleocene faunas, which is absolutely bizarre. So, we will really focus on the diversity of this very important class of animal and the journey of 50 million years from the Induan of Panchayat formation, surviving the early Triassic, middle Triassic extinction, surviving the middle Triassic, late Triassic extinction to the Carnian, and then surviving a late Carnian pluvial extinction event, then going to the Norian. So it is not easy for any animal to survive this long story in one particular country or in one particular stratigraphic region in the modern context. And we get all of it together as stacks, as bizarre preservation. So I have just tried to give a idea of where do you get what. So I will not read out because that would be really very boring. But as you can see, the in the early Triassic part, you have species related to Madagascar, Spitsbergen, Russia, North America. In the middle Triassic, the exact same species and sometimes the exact same genera is present in Australia, Europe. And then Metaposauridae, that is in the Carnian, the species is so widespread, the Metaposauridae family, it is present all over Europe, all over like Gondwana, India, and most places. But again, if you come to the Triassic Cretaceous boundary, then it is present again only in the Gondwana countries and solely in the Gondwana. So, this diversity is what makes India a very, very unique continent for comparison, even during the Gondwanas. So, let's take this as a movie. So, we have the first act, the act one, which is the first recovery after the Permo-Triassic mass extinction. So this is a field photograph because I think no picture in India it would be perfect without giving some field photographs. So like every other Gondwana deposits, we have multi-storied sandstones here with amazing picture perfect cross laminations and mudstone sandstone units in alternation. But the fossils here are peculiar. They are very tiny, very broken, and found in conglomerates or just along the riverbeds. I mean, it's a painful act to find them, and even more painful act to join them and study them because there are hundreds of fragmentary material which you have to find the minute little details to join them together. Thus you can understand that the post-extinction world was dominated by just a single disaster species, and if any one of it could be really named as a disaster species, then it should be a species called Aphaneramma, which by this jaw, which is present on the right hand side of the screen, you can understand that it is very long snouted because this one you have in the middle Triassic also, and they were one of the most successful groups which you also found in different niches from the marine part and to the shallow marine parts also and freshwater. So, but it is to be noted that while Aphaneramma was controversially one of the most successful ones, you did have other species all within the same Panchayat formation, and just believe it, but believe my word for it rather. I have given the names of a few, otherwise it would take up a whole lot of the screen space. This disaster amphibian were nearly 11 families, all staying within various sub niches of the Panchayat formation. So, if we just try to imagine a space, an ecologically empty space, so we have fully aquatic open water Aphaneramma, which is still small. We have kind of small, yet a little larger than Aphaneramma, which is called Indobrachiops and Benthosuchid. And then we have marginal or terrestrial Listosaurus, which are not at all amphibian. But amphibian is again Lidecarina. So if I do the amphibian curve, then you have Aphanerama indobrachiops in purple, then Benthosukid and this Lidecarina, this kind of a normal density curve, and this Lystrosaurus is an outlier which is completely terrestrial and not an amphibian at all. But they kind of roamed, and it provides us a good outlier of the niche that is the same niche which was shared by the amphibians. So there was a competition for resources, which makes it very apparent. Now we cut everything and come to Act 2. Like the scenery is completely changing. The lush green forests have started to occupy. So this is deep within the tiger reserve of the Satpura Reserve Forest. And if you are lucky enough to do field work here, you can even find pug marks of tigers and babies, like little cubs. Well, it's not really a happy thing to find when you are doing the field work, but it nevertheless is exciting. And it was also a developing ecosystem. There was plenty of freshwater lakes, and the disaster taxa changed from being a disaster to being giants. So now, boom, all the little minute temnospondyls became absolute giant. It was a game changer. So the small to medium survivors, so by the way, in the early Triassic, there were also these capitosaurs in the Panchit Formation. We do not have any skulls of them, but we do have small, tiny jaw fragments that we have recovered. So those capitosaurs, once they crossed the early Triassic to the middle Triassic, they became gigantic. So this is a recent published work by Roy et al. And they were meter sized long. And most of these animals, you can have a look if you go to the Geology Museum of the Indian Statistical Institute. They are well preserved there. And these are all found in the Denver Formation. They have very large jaws, like jaws which can easily crunch an alligator together. They are like really large, and it is estimated that the total length would be nearly 4 meters. But one thing which is a pretty new taxa and we have still not reported, so it is really a hot taxa for us, is a brachiopid, which we kind of think we would call the Melisaurus. It had the adductor fossa very long, like the fossa itself was very wide, and the retroarticular process was very long, and that gave the depressor mandibulae a very strong force, a very like a majestic force to crush whatever it comes in the way. But this animal was not really as giant as the capitosaurs, and these kind of semicircular area you see near the skull, they were large cheek emargination, like large vacant area which were completely occupied by muscles, which actually added to their immense jaw strength. So basically it was a river system, a freshwater system where you have monsoonal flood and the beginning of seasonality in India. And then you have a lot of fish fossils. We find, like just like the Amazon drought scenario, we find one layer of mud, fish fossil, the second layer of mud, temnospondyle and fish, the third layer, temnospondyle and fish, and it's immaculate. Some layers are monospecific and some layers are multispecific. So, like, what does this actually tell you? There is also, we did a global compactness, but that really is not showing here for some reason, this video. But from the mean compactness of 0.8, that is a bone density, it all went through 0.5 in the middle Triassic. Now cut the act and let's go to the late Triassic. Now, if you can see the name here on the screen, it is Metaposaurids and Chicotosaurids. So remember, in the early Triassic, there were 11 families. In the middle Triassic, there were at least 4 that we can see from the screen. And in the late Triassic, there were only 2. So the diversity was decreasing, but their size, their gigantism was massive. So this is a part of a reserve forest in Telangana, India, which is called the Kagasnagar and the Sironcha Reserve Forest. It is pretty hard to do field work here because it is thorny bushes everywhere, but it's also bizarre. So here you have the fresh flat-headed monster, which are called the Metaposaurus. And this reconstruction was built by a good friend of mine, Sudipta Kalita, who is now presently in his PhD. But the interesting part of the Metaposaurus is that you have this animal all over the world, like all over Pangaea. But the Indian part is very unique. So basically, the Indian part have features or have specific features of its anatomy which are related to both the European counterpart and the Gondwanan counterpart. And it is spooky. But here the story doesn't end. We did some histology and we found that the Indian Metaposaurus, which is also called the Panthosaurus malariensis, actually had a very, not a very slow growth, but a slower growth over a longer period of time. And you have a cessation of growth in every seasonality. So, from this bone histology, we can also say that seasonality was pretty well established in India at the Carnian of the late Triassic. But this is not the end of the story. Now it reigned consistently for 2 million years. And we have the Carnian pluvial episode, which, according to Professor Benton and all, is extinction even, and rightly so, because apart from the extinction of many other animals, we also find the complete extinction of the only amphibian present in the Carnian, that is the Metaposaurus. But that left immense amount of vacant niches, which were occupied by the Chigutosauridae, or the other group of amphibian called the Chigutosaurs, which were absolute giants. We recently, so it is a publication which is still under review. So I'm only showing some of the commonly widely populated pictures out of it. So here you have that the entire Chigutosaurus bone histology, and we can say that their growth was more similar to that of the amniotes, and getting a lot of vacant niches left by the metaposaurs, tremendous amount of rainfall, and the start of the dinosaur diversification event after the Carnian pluvial episode, the Chigutosaurus were no less. They were absolutely broad table skulled animals like Brachycephalus, short skulled animals, but they were huge giants and they grew very fast. They grew fast over a short period of time. So we do not yet know how long the animals lived, but we know that as long as they lived, they never stopped growing, and they grow very, very fast. So this really makes India very special, because from the tiny miniaturized amphibian to the late Triassic, surviving three mass extinction, with reducing diversity, we have the conquering gigantic temnospondyls. And if our analysis is correct, we might have the largest Chigutosaurs from India. So as I'm repeating myself, so this is towards the end of the talk. That is the Act 4. Why, what India changes? Why is it even worth studying? So one, diversity versus disparity. The taxon counts declines through the Triassic as the families drop out. So from 11 families, you have 4, and then you have 2. And then the disparity. So we did a lot of morphospace calculation, and we see that the disparity actually expands into the middle Triassic before again narrowing into the late Triassic. But that is again a point of debate among many. But what is more important is the extinction restructuring, again, a nature's experimentation, all read in one continent rock, in one area, one peninsular India stratigraphic record, and sometimes as a continuous stratigraphic sequence. Especially if you go to the Satpura Reserve Basin in Denva Formation, below the Denva you have Panchmadi, which is early Triassic, then Denva, which is middle Triassic, and you can go up to Bagra, which is early late Triassic. Same for Malaria and Tiki, you have the entire sequence from early Triassic to late Triassic. So we preserve all the micro extinction and the little by little species specific changes these amphibians underwent. So when you see like documentaries about why temnospondyls were important, because they gave way to the modern salamanders. So they were important in transitioning from fish to amphibians. And additionally, they were very important in the extinction boundaries they crossed to give rise to the modern amphibians. So, yes, before the dinosaurs, there was a world occupied by the fishes, and a world dominated by the temnospondyls. which do not deserve perhaps as much respect as they should have. So, with this, I would like to end my talk, and I would like to thank Paleo Purse or Paleo Perks for this great opportunity to present the temnospondyle, because as I always get excited if I have to present specifically on this animal as a broad diversity, because among all the topics of paleobiology, histology, paleoclimate, I think temnospondyles were index taxa and disaster taxa at the same time, and they deserve way more importance than they actually get. And thanks to my institute in Germany, which is State Natural History Museum Stuttgart, and the Indian Statistical Institute, which gave me the foundation to an enormous world of statistics and paleontology all together. So, yes, thank you, and I would be happy to answer any questions that you would have.
Great. Thank you so much, Sanjukta, for a great talk and summarizing like some example from Indian continent. Really interesting. Thank you so much for great talk. And I request everyone, please, if you have any question, any doubt, send it to the chat box or to the question exhaust. And I think we already have few questions. First question is, I will drop into chat box. Okay, you can read there also.
So,
First,
to access the chat box, I need to stop sharing.
no, directly. I will read out. It's fine.
Okay, sure.
So the first question is, why were giant amphibians so successful after the Permian Triassic mass extinction during middle or late Triassic?
Okay, so yeah, the very good question. So after the Permo-Triassic mass extinction, the giant amphibians were not giants, so they were very small and they were not that successful. But their success story actually began in the early Triassic because they actually diversified a lot. So they split themselves, if you study worldwide, nearly into more than 30 families, or if I'm not wrong, more than 40 families. And when the middle Triassic crisis came or more rainfall came, the paleo environment changes, they got more resources to grow up, like to grow into giants. And the dinosaurs were not large, or the archosauromorphs were not very large. So in India we do have archosauromorpha and others like Stringosaurus indicus, but they were not really very large. So the temnosponda, so the amphibians, really had a heyday where they were not afraid of a lot of predators in the middle Triassic, and they could grow to their heart's content. But the situation was a bit different in the late Triassic, though, because in the late Triassic, you do have the phytosaurs coming in, and the phytosaurs were also changing their species and putting up a great competition. And we do not know why in India actually these animals were extinct in the late Triassic in the Norian, because these specific temnospondyles did continue to Cretaceous in Australia. But we think that towards the end, or that is towards the late Triassic, they faced a lot of competition with the dinosaur diversification, even DDE after the Canyon pluvial episode, that slowly made their decline. But as for gigantism, yes, so from the middle Triassic, when it comes to the late Triassic, seasonality was introduced. There were more freshwater ecosystems around the Gondwana, and so they had more nutrition and more resources to grow. The competition was still less. And after the Canyon pluvial event of the late Triassic, when you go from Canyon to Norian, they were giants because there was a vacant niche left by the Metaposaurus, which they could exploit. And that is one of the reasons I told that from histology, we see that the Metaposaurus grew slowly over a long period of time. Like, it is more of a relative comparison, but they grew over a long period of time. Their gigantism is achieved over a remarkable period of time, which was larger than the Chigutosaurids. Because the Chigutosaurus, which occupied the Metaposaurus's vacant niche, and exploited the extremely high nutrition and the vacant niches carved out by the Metaposaurus, did also face a large amount of competition from the evolving phytosaurs and the dinosaur diversification event. So they had to grow very fast, and that led to large growth in a small sequence of time. So the reasons for gigantism is varied, but that they led to gigantism because of enough nutrition and also because of lack of predators, variable over the different extinction boundaries. That is the truth. So I hope I could answer your question.
Yeah, thank you. Thank you, Sanjukta, for detailed explanation. And I think we have another anonymous question. which is like, what do you think is the biggest gap in our understanding of Triassic ecosystem in India, and what kind of fossil discovery would most help fill that gap?
Could you repeat the first part of the question? I didn't get it.
What do you think is the biggest gap in our understanding of Triassic ecosystems in India?
Biggest
And
gap.
biggest, yes.
Okay. So yes, now I can remember of only one dominant thing, because I think being a dominantly a Triassic worker, I face a big part of challenge is that we do not have any Triassic dating in India. So, whereas very concise chronostratigraphical datings are available in Brazil and other counterparts which have very similar species to India, we do not have any in India. So, and because of funding issues and definitely other logistical constraints, and that is the biggest and the most important gap, according to me, apart from the fossil discoveries, because India does have a lot of fossil discoveries, and being a developing nation's funding is a problem. But if you say me about one most important gap, that is the dating, because we are still using comparative stratigraphy and a bit of quantitative stratigraphy for comparative dating, or comparative geological time scale. But in most cases, I think they will differ if we have the precise dating. And what was the second part of the question, if I may have?
Yeah. Second part was, what kind of fossil discovery would most help to fill that gap?
Okay, so the gap I spoke about is actually a stratigraphic gap. So, and fossil discovery, let's see. I think I would like to have some brachiosaur from India, from the Permo-Triassic or the Permian of India, to see exactly where the Permo-Triassic extinction line went through. Also, some well-established benthosuchids from India, because the Indian benthosuchids are cannot be determined at a specific level. They are so fragmentary. And procolophone, something we do not have in Indian Gondwana and we have in all the other Gondwana deposits. They are not temnospondyls, but procolophones from the early Triassic will be one of the key discoveries that could change the whole Indian early Triassic discovery of the Panchet, or any early Triassic Gondwana for that matter. Middle Triassic, I think we have a pretty complete record, and in the late Triassic, I don't know. We have enough dinosaurs at the present. At present, and temnospondyls also, we have the most key discoveries. But I think I would like to have some complete specimens of pterosaurs from India, because the Indian pterosaur record is a single pterosaur, and that also only one teeth. So I think that could also change the whole dynamics of Indian late Triassic, and especially the Triassic Cretaceous boundary.
Good
So
suggestion. Thank you.
yeah, that's
Thank
it.
you. Thank you for your reply. And I think we have another question from Junaid Zariawala. A amazing talk, very interesting. I cannot remember the amphibian name now, but it was the species where you were talking about the lower jaw. You mentioned that it was strong. Why did they evolve such a strong jaw? And were they able to crush shells or bones of their prey? How strong was their bite? Thank you.
Thanks, Junet, for your compliment. Yes, I know exactly the amphibian that you are talking about. So I think you are talking about the brachiopid, which is yet to be published. But the question that you are specifically asking, that were they able to crush shells? Yes, we do have evidence of chigutosaurs, which are in the late Triassic, which had massive jaws, and they in the jaw areas, we did find very large unio shells, like unio fossils, embedded within the jaw, and the crunching behavior, because like when we did some taphonomic evidence, we did find signatures of bite and crushing by the animal. So yes, they could actually, some of them were suction feeders, and they could actually take on shells. But you might be interested that the chigutosaurs actually could pull down small archosauromorphs. Like they lived more or less in swampy areas, and they could actually pull down at archosauromorphs. And we do not have actually an estimate, a precise estimate of the bite force. That is something we need to do with finite element analysis. We do have it for some other animals, but not precisely for these giants of Gondwana, which were much more gigantic than many of their European counterpart. And that is a project actually in development. And your other question, why did they have such huge bite force? Well, I think they had enormous palatine cavity and a huge bulk of muscles, and that actually helped them to compensate for the retroarticular process with the sheer load bearing of the musculature. Because if you ever see a temnospondyle palate, you will see that they have enormous grooves for muscle, especially the short faced ones. So we think from a comparative anatomy. So we don't, as I said, we don't have an exact quantitative bite force as of yet, but we think that the short faced ones, sheerly due to their load bearing of the enormous muscle quantity, uh, could have a crushing behavior. I hope I could answer your question.
Thank you. Thank you, Sanjukta, for explaining to Junaid. I hope that's satisfactory for the Junaid. And we also have another question from Hamza.
Yeah.
Have you tried comparing your result to those from Permian Triassic landscape in current China to trace out the evolution of species that survived the extinction?
A very good question. Actually, no, I would love to do that, but currently I don't have much contacts in China. And I am establishing a few contacts, but if anybody would like to collaborate, I would be more than happy, because it is really something that we are looking up to, of comparing these, because China has enormous amount of exquisite preservation. So now that I know the fossils from many parts of the world, the temnospondyls, I would love to know some or compare these with the Chinese counterparts. And yes, if anybody can give me good contacts or wants to collaborate, I would be more than happy to do so.
Yeah, thank you. Thank you, Sanjukta. I think I remind everyone, please, if you have any doubt further, please put your question into the chat box. We have, I think, just last question here in the chat box, which is like, how is consensus on a stratigraphy formation made in your community? Do discussion happen in meeting or through the academic journals?
Yes, it happens through meetings, through academic journal, through established dating in equivalent formations around the world. So there are many ways to reach a consensus, but one of the best is if we could do a chronostratigraphic dating, which is currently unavailable in India. But in paleontology, since sedimentological dating is sometimes a bit challenging, it is a widely accepted way to compare equivalent formations all throughout the world, and then narrow down your estimations. And then, yes, we have peer reviewed journal publications and meeting. And there is the stratigraphic commission meeting where things get reviewed every now and then with respect to the taxa. So, yes, there are many ways to do it. So, we know that our dating is quite precise, but perhaps not precise to the level of one or two million years, I would say, because in time scale, million years are a lot. So perhaps not to that level, but in a broad daylight, it is pretty precise.
Great, thank you. Thank you so much. I think we have just last another question. Question is, excellent talk and exciting research findings. Does your research have any implication for fossil heritage conservation in India and other regions? Are is essential outcrops withering away or under threat of development?
Okay, thank you very much for liking the talk. Yes, you have hit the hammer on the head. So, India currently is conserving fossils. We have heritage sites. We have dinosaur egg sites, Jaisalmer dinosaur sites in not Jaisalmer, Jabalpur being preserved, but the Temnoswandal sites, unfortunately, have not yet been like declared as fossil heritage. But we are continuing our mission to do so. And really, like I had an engagement grant from Paleontological Association where we focused mainly on conservation. But it's a bit difficult in a country which is having the world's largest population, because urbanization is important, and not all people who are into urbanization does understand fossil. So it is kind of a win and lose scenario, but I would say it is better late than never. So right now we do have a lot of geoheritage sites, especially with fossils, but not exclusively in the Triassic, I would say. But I really look forward to having some in the future, because I know that the government is taking initiatives to do so. So yeah, let's think for the better part of the story, because we are doing. So it might be slow, but it is there.
Thank you, Sanjukta. So I think with this we can just end the talk. And thank you very much.
Thank you very much. Should I stop sharing?
Yeah, can you just stop?
Yep. Okay.
So thank you so much everyone for being here. And then please don't forget to fill out the weekly feedback form so that we can learn a bit more about who has attended today's seminar and what are their feedbacks. And for our next seminar, we are not like still sure about the date and timing. And definitely we will inform you all through follow-up email or through the social media advertisement. And next, it's about tea time. So as I mentioned earlier, that tea time is not like is just like a informal conversation about the talk in more relaxed settings. So if you have any further doubt, so please stick around. And before going to tea time, we will have a 2 minute break. So please get up and walk around and have a quick drink of water, and then see you in 2 minutes.